Hello everybody and welcome to today's lesson on factoring. Today our objective is we will be able to factor trinomials when a is equal to 1. So what is factoring? Factoring is a method to solve quadratic equations. Oh, and what are quadratic equations? A quadratic equation has the general form ax squared plus bx plus c. So you have a term with a variable that's squared. And in the general form, you have a, b, and c. And those are just placeholders for any integer that you could plug in there for a, b, or c. For the purpose of factoring, we're going to have to use these numbers to find two things: the target sum and the target product. The number that stands in the place of b is what we call the target sum. And if we take the number that's in the place of a and multiply it by the number that's in the place of c, we get the target product. Target sum abbreviated TS, target product abbreviated TP. Let's look at some examples and see what we're really talking about here. And when we find the target sum and the target product, we can write them down in different ways. I suggest this way: make a big cross like that, put the target product in the top area here and the target sum in the bottom. So our target product is a times c. So the coefficient of our squared term, we don't see anything here, and that is really when a is 1. So 1 times 9. And remember our learning objective. Today we're really going to focus on factoring trinomials where a is equal to 1. The target product is 9. The target sum is going to be the number that's in the place of b, and that is negative 4. We could go ahead and factor now, but we're not ready for that just yet. Just notice how we find target product and target sum. Let's move over to the other side, make our cross, and here it's a little different. Here we have a number that's 3, that is a, and a times negative 10 is negative 30. So the target product this time is negative 30. The target sum is 13, and that is b, the coefficient of our linear term. Once we have found the target sum and the target product, we need to find two numbers that can do two things. When we add them, we get the target sum. That's why it's called target sum. We add those two numbers, and when we multiply them, we get the target product. That's why target sum and target product get that name. We multiply those two numbers, we get the target product. We add those two numbers, we get the target sum. Those two numbers also have names. We usually call them P and Q when we use them in certain formulas. Before we can really start factoring, we need to make sure that that trinomial that we want to factor does not have any greatest common factor left in the three terms that make up the trinomial. So the first step of factoring is to find the greatest common factor, also called GCF. And we really have to look for that every single time, otherwise our factoring can go wrong. We may not always find the greatest common factor, but we have to look for it every single time. Let's look at some examples how we find that greatest common factor. And I'm going to do this the long way. You don't have to do it the long way every single time, but in order to see it, it makes a lot of sense to look at it like that one time. I'm going to take each of these terms and I'm going to split them into their prime factors, and then we can really see what each of the terms have in common. So the number 6 can be split into the prime factors 2 times 3, and then we have x cubed, and x cubed is x times x times x. Then we look at our 9x squared. 9 is 3 times 3. X squared is x times x. And then we have negative 12, which is 4 times 3 times x. And now let's look at these three groups of factors and single out what they all have in common. And what we see is they all have a 3 and they all have an x. Not all of them have a 2, a 3, or a 4, and not all of them have more than one x. So this is all we can find. That is our greatest common factor. So we can take our greatest common factor outside, and in parentheses we put everything back inside that we didn't pull out. So from our first term we have 2 times x, so 2x squared. For our second term we have 3x, and for our last we have -4, close parentheses, and here the greatest common factor is taken out, and we could now go ahead and factor the trinomial in parentheses. Let's look at the next example. Let's do the same thing. 5y cubed. So 5 is already a prime number. 5 times y times y times y minus 3 times 5. -15 is -3 times 5 times y plus 3 times 2 times 5 times y. What do we have in all three groups of factors? We have 5 and a y here, a 5 and a y here, and a 5 and a y here. Those are the factors all of them have in common. Nothing else is left that all three groups have in common. So 5y goes on the outside, and what is left is y times y, which is y squared, minus 3 times y, plus 3 times 2, which is 6. And done, we've found our greatest common factor. Very often our greatest common factor is just a number, not a variable, but just a number. And that may be easier, but at the same time, that may be also easier to overlook. So let's also always pay attention and look out for those ones. So 8 is 2 times 2 times 2. X squared is x times x. Minus 16. Oh, so now we got 2 times 2 is 4 times 2 is 8 times 2 is 16 times x. And we got 20. 20 is 2 times 2 times 5. Have a look at those. What do we see? We don't see x's in each group. So x is not a common factor. What is a common factor is a 2, but actually 2 2's can be found in each of these groups, and that's our greatest common factor. 4. So what's left is 2x squared minus 4x plus 5. Again, sometimes the greatest common factor is just a number, but even if it's just a number, it's just as important to pull it out before we start factoring, or we're going to get into trouble. Once we have checked for greatest common factor, we can now go ahead and find our target sum and our target product, and also P and Q. And as we said, P and Q are the two numbers that, if added, are equal to the target sum, and if multiplied, are equal to the target product. When we have found those two numbers, what we do is we set up two sets of parentheses, and what's in those parentheses is what is our actual factors. Those are our factors, the numbers inside of those parentheses, and we're going to put an x into each of those parentheses, and then we're going to put p into one of them and q into the other one. Let me show you with an example what I'm talking about. We have the trinomial x squared plus 6x plus 8. So let's make our cross. Let's look for the target product. 1 times 8 is our target product. 6 is our target sum. So which two numbers can be multiplied to give us 8 and the same numbers added to give us 6? Sometimes that's easy to pick out. Sometimes it's a little bit more complicated. If it is, I'm going to show you another little trick, my factor rainbow, because that really helps us to make sure to find all the factors in groups of 2, and then we only have to check those groups of 2. What are factors of the number 8? Of course, one is and the number 8 itself. So 1 times 8 is 8. What's next? We got 2, and 2 times 4 is also 8. That's another group. So between 2 and 4, the only other option is 3, and 3 is not a factor. So this is our factor rainbow for the number 8. It's a pretty small one, but so be it. And now we can see 1 plus 8 isn't 6, but 2 plus 4 is. And those were the two numbers we are looking for. So we're ready to go. Set up our two parentheses. X goes into each of them. And 2, positive 2, goes into one. And positive 4 goes into the other. And we're done factoring. Good job. Let's do a couple more examples to get the hang of it. Sometimes numbers are negative. We want to see how it works with those. Here is our cross. What is our target product? 1 times negative 15, so that's negative 15. And the target sum is 2. So what could be the numbers that give us negative 15? And remember, if the product is negative, that means that one of those two numbers had to be negative. Let's do a little factor rainbow, and you don't have to do that one every single time, but I'll show you a couple of times so you understand how it works. And when you get into trouble finding P and Q, then do your factor rainbow on paper, and you will have all the pairs that you need, and then you go through those. 1 times 15, 3 times 5. It's another one that's not super large. There's nothing else left. So how could this work? One of those two numbers has to be negative, and when we add them, they have to be 2. You can try out all different options. Negative 1 plus 15 doesn't work. 1 plus negative 15 doesn't either. 3 plus negative 5 doesn't, but negative 3 plus 5 gives us positive 2. And we have P and Q. Set up our parentheses, X and X. And now we plug in negative 3 into one and positive 5 into the other. And again, you're done factoring. That's not too bad, is it? Last example for today. X squared minus 7x plus 12. Our target product is 12. Our target sum is negative 7. So how can this happen? We have a positive product but a negative sum. Well, then both of our numbers that we're looking for have to be negative. As we multiply two negative numbers, we get a positive product. Yeah, that works. But when we add them, the sum is still negative. And again, my factor rainbow here, 1 times 12, 2 times 6, 3 times 4. Those are all the options we have. There's nothing left. This way, we never forget a number or even a whole pair. And then we just go through those to find the right two numbers. Negative 1 plus negative 12 is not negative 7. Negative 2 plus negative 6 isn't either. But negative 3 plus negative 4 is negative 7. And here go our factors. In parentheses, x minus 3 and x minus 4. All right, you guys, so much for today. For factoring trinomials when a is equal to 1. And in the next class, we're going to talk about factoring when a is not equal to 1. Okay, I'll see you in class.